Hi, this is Mrs. Secor, and if you can find this page in your notebook, we're going to continue with our problem-solving proportions. Well, we can see that the man's height is 5 feet, and his shadow is 8 feet. The height of the evergreen tree we don't know, so we'll call it X, and its shadow is 32 feet. This is a proportion, so we'll set them equal to each other, and we'll use our cross products to solve. And we get 8x equals 5 times 32, which happens to be 160. And we'll divide both sides by 8, and we get 20. 20 feet. The evergreen is 20 feet. You know, I'm so possessed on these proportions, but looking back at this problem, I can see, well, gee, I didn't even have to do any work. I know that 8 times 4 is 32. So 5 times 4 is 20, making equal fractions. Remember, I told you, proportion is just multiplying. Sometimes, though, it doesn't work out that nice, and we forced to use our cross products. Like this one. All right. Narachi enlarged the size of a rectangle to a height of 0.8 inches. What is the new width if it was originally 0.4 inches tall and 1.9 inches wide? Again, I really would like for you to use labels. And I'm thinking tall and wide on this one. 0.4 inches tall and 1.9 inches wide. And then let's see, it says height of 0.8 inches. So that would be tall, right? And X on the wide. Okay, so we'll use our cross products. And we'll get, oh gosh, I guess I do see that if I multiplied by, what, 2? That would give me the answer, wouldn't it? Okay. Well, if I did multiply by 2, I didn't see that off the bat. I should end up with 3.8, I think, at the end. So let's see, what is 0.19 times 8? And then divide both sides by 0.4. Oh, good. And we get 3.8. Okay, the next one. 5 inches tall, the photo is. This time we're going to reduce it. 6.2 inches wide. Okay, and then it says we're going to reduce it to a height, that'll be tall, 2.5. This is X. Oh, brother. I see this one could just be divided in half, couldn't it? Half would give me 2.5, so this should turn out to be 3.1. Oh, my goodness. Oh, well, let's use cross products. 5x equals 2.5 times 6.2. I think you get 15.5. Then you divide both sides by 5. Yep, we get 3.1. All right, next page. The money used in Sweden is called the kroner. The exchange rate is 7 kroner for every $1. Find how many kroner you would receive if you exchanged $2. Oh, brother, this one we surely don't need. Cross products. But let's just set it up. If 7 kroners gives me $1, if I get that for $1, how many kroners am I going to get for $2? Okay, everybody. How many kroners? 14. 2 times 7. Easy. Okay, next one. Oh dear. Abrahazra was planning a trip to Croatia, and before going she did some research and she learned that the exchange rate is 6 kuna for every $1. How many kuna would she get if she exchanged $2? Uh-oh, easy again. 6 kuna for $1. How many kuna for $2? Okay, everybody, what is it again? Just 6 times 2, you're going to get 12 kuna. All right, let's move into similar figures. Same idea. We're going to need to set proportions to find our missing side. Can you see how this side, 4.8, corresponds to this one? It says they're similar. This side corresponds to this one. And this 51.8, I'll just put a box around it. That corresponds to this base, right? Or this triangle. So we can set a proportion. I'm going to use the one 48.3 over my 51.8 equals 6.9 over x. I'm going to use my cross products and find out what x is. Okay, I think I get 48.3x. I do this, equals, and then this product here is 357.42. If I divide both sides by 48.3, it looks like 7.4 is the length of this base right here, 7.4. Another one. We have a rectangle, and we know they're similar because it was given to us. So the height, x, over the base, 18.4, right? I'm going to go this over this base is equal to the 9 over the base, 2.3. I'm doing these symbols because on your class work I start to rotate them, and you have to figure out what corresponds to which side. So if we do our cross products, we'll get 2.3x, and then 9 times 18.4 is 165.6, and if I divide both sides by 2.3, I think I get the answer 72. So this x is 72. Now, there are many different ways to set up proportions, and I just thought we'd look at a few of them that are acceptable. So if I say, well, let's compare A to B, what ratio could I write that is equivalent from A to B over in the big triangle? A to B, wouldn't it be F is to D? And then if I say D to F, then when I say B to A. And if I compared this alongside A to C, over here it would be F is to E. Let's just try one more. What if I said, oh, B to D, going across B to D, then A would correspond to F. Oh, we can even continue this. And C would correspond to E. Those are all equal, those ratios. Okay, one last problem. Sometimes you're given quite a bit of information and you have to solve for two variables, so let's do one. Well, we can see if we have to solve for x, the side that corresponds to that is 12. And I think we could use this side and this side. We have two givens. We'll put boxes around those, okay? So 10 corresponds to the 7.5 and 12 corresponds to the x. All right, I'm going to set my ratio as box over circle. So 10 is to 12, box over circle, as 7.5 is to x, box 7.5 is to x. I'm going to use my cross products, and 10x equals 12 times 7.5. I think that's 90. And so x equals 9. Okay, and then we need to find y. Y, put a cloud around it, and this one is 6. They correspond to each other. Again, let's say box is to cloud as box is to cloud. Okay, so box is 10, and its cloud is y, and 7.5 is to 6. Now I have 7.5 times y equals 60. This product is 60. And then if I divide by 7.5, I think I get 8. So y is the value 8. Okay, and thank you.